cut. This is Possible Team presenting our game Snake and Ladder. Now the game consists of very many components, including a set of LEDs, which in total are 64. Each set having four LEDs at each set, each LED representing player position, ladder position, and the snake position. The LEDs are controlled by decoders, have player decoders to control player movements onto the game module. We used 4 into 16 line decoder to control different positions from 0 to position 15. These are active low decoders. Then for the ladder and the snake, we used two decoders. The For the ladder we use two decoders, one for the ladder start and another one for the ladder top, meaning we can know the length of the ladder using these two decoders, and the corresponding LED is lit up to know that position. For the snake, also has two decoders, one which is the snake head decoder and the snake tail decoder. To know the length of the snake, we subtracted the head from the tail. Now, the snake head and the snake tail plus the ladder start and ladder end are stationary on the game mode. You see, they are at position. We have ladder at position 3 and position 6. We again have the snake at position 8 and position 12. These ones were stationed by the decoders. We can adjust these positions by simply changing the different positions using the decoders. Now, for the logic part, our logic our logic has a total of six inputs. One is the dice input, the dice values, the 2 bits from the dice. Then either player A or player B inputs. Then we have the ladder start, we have the ladder top, then we have the snake start and the ladder and the snake head. Our logic works in a straightforward manner by simply works in a straightforward manner by simply its role is to get the tentative position that is stored in our memory. It does this by adding the player selected value plus the dice value. Then after that, we do the comparison to see whether this tentative position is either equal to the ladder start or the snake head to adjust the positions accordingly. Now, if this tentative position is equal to the ladder start, this tentative position is increased or added, is increased using a adder to the ladder start, and the person is elevated to the top of the ladder. Now, what if this tentative position is equal to the snake head? This tentative position is decreased by the snake, is decreased is decreased by the snake top using the subtractor, and the person falls at the start of the snake. To implement this, we used two comparators, adder and subtractor. Then, to get the final output, we used three maxes to output the final position. Now there is another case where this tentative position is neither equal to the snake head, nor does it equal to the snake, neither does it equal to the ladder start. If it doesn't equal the ladder start, this position goes straight through and the game adjusts accordingly. Now, this is our logic. For the memory part, our memory, our memory has our memory has our memory has a total of 7 inputs. One is the dice clock pulse, and another one is the tentative position from the logic that is stored is either for player A or player B. Then the player selector button, the reset button, and the iClock pulse to control the memory. Now it has three outputs. It has an output for player A, an output for player B, and the final output for the selected player to be adjusted on the game module. Our memory part, our memory has two parts. One has a part for storing details for player A, this is the upper part, and another set of the memory is to store results for player B. To activate the memory part is activated by a switch, whereby if we give active if we press the switch, meaning we give positive 5 volts, player A memory part is activated and player B is off. For this, to demonstrate this, running our game by pressing the dice, one, two, then position, we see position 1 is being stored. Going to the child sheet, we see that player B is at position 1, and we see player B, the blue arrow ED is adjusted to position 1. Now to test for player A, we switch off. To test player B, to store player B, we switch off, then run the game again. Mm. Now we see again player A is at position 1. See, as you can see, both player A and B at position 1 of the game module. The memory part is activated by pressing the switch. When you press the switch, meaning is 5 volts, player A activates. When we unpress the switch, player B memory part is activated. The memory the memory is activated by the iClock pulse, which we made using 555 timer IC. As you can see, as you can see, this high frequency pulse is so fast to activate our memory. Then going to our dice, the counter part. The counter was designed in order to produce pseudo random values counting from 1 to 3, because we don't need 0. We made some adjustments into the designing of the counter, including these logic gates to eliminate the 0 output. The dice is activated by the low frequency pulse, which is seen as follows, which we made using 555 timer IC. As you can see, this frequency is changing slowly to generate stable values. Now, from that, the memory consists of the winner module. This winner module the winner module was designed to predict who the winner of the game is, and this was made using two 4-bit comparators to compare player A and player B on the game module. Now, if player A is at the highest position, that is at position 15, player A wins, and his corresponding LED lights up. Now, if player B is at position 15, his LED lights up and he wins the game. Now the whole game, to reset the game, we used a switch, which when we place it, the whole game resets. The whole game resets to 0. The whole game resets to 0, as you can see. The game resets in the memory as this reset logic was also activated using the high frequency pulse, which either activates or deactivates the flip-flops of the memory part. Now playing the game, uh, we see we see that now player A, player A, the dice has given us 3. Now adding 3 to the tentative position, we get 6, meaning the player has landed onto the snake and his length is decreased by the snake length and he goes back to position 3. Continuing with the game, mm, running the game again. Now is 2, 2 plus 3. Now player B is at position 2, which is stored in the memory. Continuing, see, see now player A advancing to position to position plus advancing to the higher position, position 7, and continue to play the game. When we continue playing the game, see that now player B is at position 15, meaning he only needs only 1 point to win the game. Continue playing. Once he gets 1, he's at position 15, meaning that he has won the game, and his corresponding LED lights up. Thank you for watching. Assalamu alaikum wa rahmatullahi.